Hi kiddos, here's the review for Spiral 6, and we're going to start off with limits. This time we don't have any optional sections because we don't have any of the beginning of the year stuff. Starting out, we've got the limit as x approaches 2 of 2x squared minus 8 over x minus 2. I'm going to try plugging in 2 to see what happens. We get 8 minus 8 over 2 minus 2, which is 0 over 0. That means this limit might exist. So let's do some factoring. I noticed that at first I can factor out a 2. That leaves me with x squared minus 4. And on the bottom we get x minus 2. I might also notice that the top now is difference of two squares. So that's the limit as x approaches 2 of 2, x plus 2, x minus 2, and the bottom is just going to be x minus 2. My x minus 2's reduce, and we've got the limit as x approaches 2 of 2 times x plus 2, which is going to be 2 times 4, or 8. For number 2, we're going to try plugging something in again. So we get negative 5 times 16 plus 20 times 4, which comes out to be 0. And on the bottom, we're going to have 64 minus 3 times 16 is 48, minus 4 times 4 is 16, giving me 0 over 0. So that means I might be able to do some factoring again. Let's factor at the top. The limit as x approaches 4. And that's going to be maybe a negative 5 coming out of this. X squared minus 4 would be the remainders in there. In the bottom, I know I can take an x out. And we're going with x squared minus 3x minus 4. That's going to factor further. So we get the limit as x approaches 4. Negative 5, and that's going to be x plus 2, x minus 2. And the bottom, it's going to be x, and that factors into x minus 4 and x plus 1, which nothing is factorable because what actually happened is I factored way back at the beginning incorrectly. This is not going to be x squared minus 4. I can take a 5x out, and I get an x minus 4. So that does not factor difference of squares. That's going to be an x minus 4. My x's cancel out. My x minus 4's cancel out, leaving me with the limit as x approaches 4 of negative 5 over x plus 1. When I plug that in, I get negative 5 or positive 5, which is negative 1. Moving on, we get a couple of visual problems. We've got this graph, and the limit is x approaches 5. Yeah, so I'm going to look for where x is at 5, and that's going over here. From both sides, we're approaching the same height of negative 2. Therefore, the limit is negative 2. We know for a limit to exist, it has to be approaching the same value from both sides. For number 4, we're looking at the value as x approaches 7. Okay, that's from both sides. We've got to check both sides. And from both sides, we approach a height of 0. Therefore, the limit is 0. It does not matter that there's an extra point there. Limits do not pay attention to this other point. This graph, however, would not be continuous because the function value, which exists, it's defined at 7 as 3, is not the same as the limit from both sides. Next up, we're adding continuity, and hopefully no big surprise, but we've got to figure out if something is continuous. In this case, it might be differentiable, so we have to add that level to this. First thing we need to do is establish continuity. And for continuity, we have to take the limit from both sides. So we're taking the limit as x approaches 3 from the left of x squared, which is going to be 9. And the limit as x approaches 3 from the right of 6x minus 9, which is also going to be 9. F of 3 uses that same function, so we can just, since we already evaluated that, right equals 9. That's okay. At this point, we say that this is continuous. Without showing the limits here, you can't earn points for this problem. You have to show the limits, both left and right, in order to get any credit for this problem. To check for differentiability, which a couple of these are asking about, in fact all 4 are asking about this, except for the one says it's undefined, which is not true because we have a value here based on the equals part. We have to take the left derivative and the right derivative. So from the left, the derivative of x squared is going to be 2x. And if I plug in 3 to see what that's approaching, we're looking at 2 times 3 is 6. From the right, we've got 6x minus 9, which equals 6. And it doesn't even matter if I plug in 3 here because we already have 6 as a value. To show differentiability, you have to show that you're taking the you have to show that you're taking the derivative from both sides. And they have to come to the same value from both sides. So this is both continuous and differentiable. So we're looking at E. In number 6, we're looking at a graph, and we've got to select things that apply here. So at x equals 5, just look what's x equals negative 5, sorry. I can see by looking at my graph that my limit's okay. My function has a value of 3, but it's not continuous here. Okay, so both the left and right limits exist. Well, we just did that. We came to negative 3 from both sides. That's true. The limit as x approaches negative 5 exists. That's also true because it has the same value from both sides. G is defined at x equals negative 5. That's what this point is up here. That's true. G is continuous. Nope. And that's not true because the limit as x approaches negative 5 of g of x does not equal g of negative 5. And if, well, some of these are true, none of the above doesn't even make sense. So we've got 3 that are true, 1 that is not, and that's it. Next problem is about I can't talk today, definition of derivative. That's what I was going for in derivative rules. It's a feedback section, so my hope is that you can use this video, the practice, and the feedback from this upcoming spiral to help improve your scores and understanding of this topic. First thing up, we've got a secant line. We've got to find the slope of the secant line on the interval negative 2 to 3, and I've got an equation to plug that into. So let's find f of negative 2, which is going to be negative 2 cubed plus 3, or 11. That's the point, negative 2 comma 11. Then let's find f of 3. And when we do that, we get 3 cubed plus 3, which is 30. That gives me the point 3 comma 30. Okay, the slope of the secant line will be the slope between the 2 points on the curve, so that'd be 30 minus 11 over 3 minus negative 2. 30 minus 11 is going to be 19. And 3 minus negative 2 is going to be 5. 19 over 5. Slope of the tangent line using the definition of derivative means I have to use a limit. I'm going to do this two different ways with both forms of the definition of the derivative, in case you feel like doing that. So we know we have to do the limit as h approaches 0 of f of x plus h minus f of x, and let's divide by h. For x cubed, I'm going to kind of do this off to the side. We're going to have x plus h times x plus h times x plus h. When you multiply that all out, you end up getting, get rid of my limit, x to the third plus 3x squared h plus 3xh squared plus h to the third. All right. I also need that plus 3. And then I'm going to minus the original function, so minus x cubed plus 3. This is all going to be over h. So in looking at this, my x cubeds cancel out. My plus 3's cancel out. I'm left with the limit as h approaches 0 of 3x squared h plus 3xh squared plus h to the third divided by h. I can cancel an h out of all three of these, and I end up getting the limit as h approaches 0 of 3x squared plus 3xh plus h squared, which is going to be 3x squared. We've got to evaluate this at x equals 5. 3 times 5 squared is going to be 75. So the slope of the tangent line uses the value of the derivative at a point to figure out what that slope is. Find the slope of f of x in general using the definition. Well, we just did that actually. That's what we did when we got to 3x squared. So if you took this in terms of the definition of derivative, you already would have gotten the answer for part C. If you want to use the alternative definition of derivative at a point, that's the limit as x approaches a of f of x minus f of a divided by x minus a. You end up getting the limit as x approaches 5 of x cubed plus 3. And that's going to be minus a is going to be 5, so 5 cubed is 125 plus 3 is 128. That looks like a 1 at the end. Let's move that over so we can actually see that. And that's over x minus 5. The limit is x approaches 5 of x cubed minus 125 over x minus 5. That's the difference of two cubes. There's no reason that you should know that. So what we might do is some polynomial long division, or synthetic division if you'd prefer. And when we do that, so we get x minus 5. I'm going to write this as x cubed plus 0x squared plus 0x minus 125. we get x squared minus 5x squared, which gives us 5x squared. And that's going to be plus 5x, which gives us 5x squared minus 25x, which when we subtract them we get 25x, which gives us plus 25, and that's going to give us 25x minus 125, which gives us 0. So this is equal to the limit as x approaches 5 of x squared plus 5x plus 25, which is 25 plus 25 plus 25, which is 75. And again, if you want to use the alternative definition of a derivative at a point, you're welcome to do so. Often you won't end up have to deal with cubics and linear terms being divided, but that's okay. For number 8, I see this as a quotient rule, where we've got the top and the bottom like so. It's asking for us to find the derivative of y with respect to x, otherwise known as y prime. We know this is going to be the bottom times the derivative of the top, minus the top times the derivative of the bottom, divided by the bottom squared. Okay, so the bottom is going to be 4x squared, 4 plus x squared times the derivative of the top, which is going to be 0, minus the top, 3. The derivative of the bottom is going to be 2x, and then over the bottom squared, that's going to be 4 plus x squared squared. That gives us negative 6x over 4 plus x squared squared, which happens to be choice A. The last section we're doing today is going to be trig derivatives and chain rule. This is a feedback only section. And this has to do with problems that might involve the chain rule as you go. Okay, for an equation for a tangent line, we know we need the derivative. We have the point already, so that's going to be good. So f prime of x, this is a product rule. What that's f and that's g. So that's going to be the first times the derivative of the second. So that's going to be second times the derivative of the first is the way that we talk about it. 1 minus 2x cubed multiplied by the derivative of the first, which is 1. And then we've got the first times the derivative of the second. This is going to be a power rule first. So 3 times 1 minus 2x squared, then times the derivative of the inside, which is just times negative 2. That's why this is in the section. And what we really care about is plugging in 1 here. So f prime of 1, I'm not even going to simplify anything up here. So we get 1 minus 2 to the third plus 1 times 3, 1 minus 2 squared times negative 2. 1 minus 2 to the third is negative 1. Negative 1 squared is going to be positive 1, so it's 3 times negative 2 is negative 6. There's my slope. Only one of these lines has a slope of negative 7, so I already know it's that one. But just to kind of cover my bases, y is equal to negative 1 plus negative 7 times x minus 1. Again, we're getting the point from up here. And when we do some simplifying, y equals, that's going to be negative 7x plus 7. So negative 7x and plus 7 minus 1 would be plus 6. For number 10, it's going to be y equals tangent of x minus cotangent of x. You need to know that tangent of x has a derivative of secant squared of x. Cotangent of x, you might know that has a derivative of negative cotangent, negative cosecant squared of x, so the negatives can cancel out. And that's going to be choice E. If you didn't remember these, you could write these as sine squared over cosine squared minus cosine squared over sine squared, and treat both of these as a quotient rule. For number 11, we're doing 3 sine of x squared plus 2x. Alright, I know that this is 3 sine of stuff, so I'm going to do that derivative first. So that's going to be 3 cosine of stuff. And now I need to do this multiplied by the derivative of that stuff, which is going to be 2x plus 2. At f prime of 1, we're plugging 1 in. So that's going to be 3 cosine 1 plus 2 is 3. And then 2 plus 2 is 4. If you wanted to rewrite this, that'd be 12 cosine of 3. For number 12, we're looking for g prime, g double prime, and g triple prime of x. So that would end up being g prime of x is going to be 9x squared minus 10x plus cosine of x. G double prime of x is going to be 18x minus 10 minus sine of x. And g triple prime of x is going to be 18, that goes away to 0, minus cosine of x. If you really wanted to, you could keep going forever and just keep taking more and more derivatives. So I guess something like g, and then we usually use 4 to differentiate that. The fourth derivative would be 0 plus sine of x. And then you'd just kind of be switching back and forth for a while, as long as you want it.